Hey guys, it's Leia. Today we will talk about how to solve rational inequalities. In order to solve rational inequalities, first move all terms to one side of the inequality and simplify if needed. Next, set the numerator and denominator equal to 0. Then, solve for x. Finally, test intervals and the values you got for x from step 3. This step is the same as the fourth step for solving quadratic inequalities. For this step, using a number line will be very helpful. Let's see some examples. First example, we have 2x plus 4 over 3x plus 9 is greater than or equal to 0. First, we want to move all the terms to one side of the inequality. This step is already done, so we can go on to the next step. Next, we set the numerator and denominator equal to 0. Then, we solve for x. For 2x plus 4, we can pull out a 2, and we will get x equals negative 2. For 3x plus 9, we can pull out a 3, and we will get x equals negative 3. Next, we will test intervals and values from step 3. We will use a number line to help us find the solution. We will mark our values from step 3, negative 3 and negative 2. From our values from step 3, we can create intervals to test. We will test intervals first. First, we will test x is less than negative 3. We will use negative 4 as our test value. We plug in negative 4 in our rational expression, and we can see that 4/7 is greater than or equal to 0, so this interval is a solution. So, we will mark it on our number line. Next, we will test the interval negative 3 is less than x, which is less than negative 2. We test negative 2.5, and we see that negative 1 over 1.5 is not greater than or equal to 0. So, this is not a solution. Next, we test x is greater than negative 2. We test 0 and see that 4/9 is greater than or equal to 0, so this is a solution, and we will now mark this interval on our number line. Now we will test our values from step 3. First, we will test x equals negative 3. We plug in negative 3 and get that our answer is undefined, so this is not a solution. Finally, we test x equals negative 2. We plug in negative 2 and see that 0 is greater than or equal to 0. So, x equals negative 2 is a solution, and we will fill in the circle at negative 2 on our number line. Now we can look at our number line and derive a solution. Our solution is x is less than negative 3, or x is greater than or equal to negative 2. Next example, we have x plus 2 over x minus 8 is less than 2. First, we move all terms to one side of the inequality and simplify. We subtract 2 from both sides. Then we simplify and get negative x plus 18 over x minus 8 is less than 0. Next, we set the numerator and denominator equal to 0. Then we solve for x. We get x equals 18 and x equals 8. Finally, we want to test intervals and values from step 3. We use a number line and mark our values from step 3, 8 and 18. First, we test the intervals. We test x is less than 8. We use 0 as our test point and see that negative 1/4 is less than 2, so this is a solution, and we mark this interval on the number line. Next, we test 8 is less than x, which is less than 18. We test 10 and see that 6 is not less than 2, so this is not a solution. Next, we test x is greater than 18. We use 20 as our test point and see that 11 over 6 is less than 2, so this interval is a solution, and we will mark it on our number line. Now we test x equals 8. We plug 8 into the rational expression and see that it is undefined, so x equals 8 is not a solution. Now we see if x equals 18 is a solution. We plug in 18 and see that 2 is not less than 2, so this is not a solution. Now we can look at our number line to derive the solution. Our solution is x is less than 8 or x is greater than 18. Last example, we have x squared minus x minus 12 over x minus 4 times x minus 2 is less than or equal to 0. First, we want to move all terms to one side and simplify. All the terms are moved to one side already, but we can simplify. We factor the numerator and get x minus 4 times x plus 3. Now we can cancel out an x minus 4. So we have x plus 3 over x minus 2 is less than or equal to 0. Next, we set the numerator and denominator equal to 0. Then we solve for x. We get x equals negative 3 and x equals 2. Finally, we test intervals and values of x from step 3. Here's our number line marked with negative 3 and 2. We test x is less than negative 3. We use negative 4 as our test point and see that 1/6 is not less than or equal to 0. So this is not a solution. Next, we test negative 3 is less than x, which is less than 2. We use 0 as our test point and see that negative 3 halves is less than or equal to 0. So this is a solution and we will mark this interval on the number line. Next, we test x is greater than 2. We test 3 as our test point and see that 6 is not less than or equal to 0. So this is not a solution. Now we test x is equal to negative 3. We plug in negative 3 and see that 0 is less than or equal to 0. So this is a solution and we fill in the circle at negative 3. Finally, we test x equals 2. We plug in 2 and it is undefined, so it is not a solution. Now we can look at our number line and we can see our answer is negative 3 is less than or equal to x, which is less than 2. Mastering rational inequalities requires a lot of practice. So for more help or practice, visit www.symbolab.com and click on the Practice tab.